Right, our next concept is buffered solutions. So we know that life, including us, can only exist in a narrow range of pH, right? So your body has an overall pH, the blood in your system, and same with, like, aquatic animals, right? They live in the ocean, they can only, or, a lake or whatever, they can only survive if that lake or ocean stays within a relatively small range of pH. And one of the issues is that we as humans are adding a lot of acid into bodies of water and really everywhere. So why, if we're adding a bunch of acid and life can only live at a certain pH range, why isn't everything dead? At least not yet. So let's first off take a look at how we're adding a whole lot of acid, right? You guys have probably heard of acid rain and other negative consequences, that come from this. So basically what we're doing is we're putting a bunch of carbon dioxide in the air, and that's from burning stuff. Whether, it be a fire or, your car or whatever, industrial processes. This then combines with water either in the air or in the ocean. It then becomes H2CO3, which is carbonic acid. Which, as the name implies, acts as an acid and releases H+ and bicarbonate. And so we have that H+, that's then acidifying the ocean and whatnot. So the reason that all fish are not dead is because the ocean has buffers. And the same thing with our blood and our body in general. We can ingest things that are acidic or basic, and we don't have to worry about dying because our body has ways of dealing with it. And one way that it deals with it is through these buffers. So a buffer is a weak acid base pair right? So it's a weak acid and its conjugate base, or a weak base and its conjugate acid. So an example of this is NH3 and then NH4 plus. This is not what's found in our blood or the ocean. This is just an example, relatively simple one. And so what we can see is we have a pair of acid-base conjugate pairs. And so what we do is we take some NH3 and some NH4, and we put equal amounts of them into solution, or not equal amounts if we want the pH to be something different. And then if we think about it, right, we have our solution. In our solution, we've got some water molecules, and now we've got some NH3 molecules and some NH4 plus molecules, right? And we're gonna do 2 of them. And to one of them, we're going to add some H plus, right? So we're gonna add some acid. And to the other one, we're gonna add some base. So we're gonna add some hydroxide, some OH minus. And remember, the pH is equal to the measure of the concentration of the H plus or H3O plus, right? They're the same thing. And so what happens when we add the H plus and the OH minus? Let's take a look. So over here, when we add the H plus, that H plus is picked up by this NH3, which then becomes NH4 plus. And note that everything else is left untouched. So if we take the pH of this, what we'll notice is that we haven't changed the concentration of H plus or H3O plus because it's been absorbed by this NH3. And so there is no change in pH. And then same thing over here. Whenever we add this hydroxide, what's going to happen is this NH4 plus is going to donate a proton to it. And then that just becomes a molecule of water. right? Which again doesn't change the concentration of H plus, and then we just have two NH3s. So again, we haven't changed the concentration of H plus, or in this case, OH minus, which would then affect the concentration of H plus. And so that's what buffers do. They buffer your solution. They give you a little bit of range. You can add some acid, you can add some base. It won't change the pH of the solution because the buffer is basically going to sacrifice itself to react with that acid or base. One issue though with buffers is logically they aren't unlimited. There's only so much buffer in any type of solution. And if you add enough acid or base, they will run out. And once they kind of run out, we can then experience huge pH shifts, right? Because there's no longer a buffer. So now we can change the concentration of H plus very quickly. And as we learned earlier, life can only exist in a narrow range of pH. So if that occurs, then, you know, whatever's in that dies, right? And there's plenty of examples of small lakes and small bodies of water that have either been acidified or basified beyond the point of where life can live there. And they're just basically dead bodies of water with nothing there. So hopefully that doesn't happen to the ocean, but we'll see.